This lesson will give you an introduction to geometric sequences. We looked at arithmetic sequences in our last lesson, and so this one is geometric sequences. In geometric sequences, instead of adding or subtracting to get to the next number, you multiply or divide. Because of course, if you multiply by 1/2, that would be the same thing as dividing by 2. So really we say multiplying, but it means multiplying or dividing. Okay? So and then the thing that you are multiplying by when you get to the next term is what is called your common ratio. Okay, so here's an example of a geometric sequence. To get from 2 to -6 to positive 18 to -54, I would multiply by -3 every time. And so that means it's a geometric sequence because I am multiplying by the same number every single time. And again, if you're adding or subtracting the same number every single time, it's an arithmetic sequence. When you're multiplying or dividing, which is the same as multiplying by the reciprocal, then you know you're dealing with a geometric sequence. All right, so in this case, I am needing to find the next term in the sequence, and you have to figure out, first of all, what you're multiplying by. And you might not know. I'm telling you, and I probably should have put this word in there, but I didn't. This, I am telling you, is a geometric sequence. I should have told you that so that you know you have to multiply or divide to get to the next number. If you don't know what you're multiplying or dividing by, then you need to take one term and divide it by the previous. So I will take 108 and divide it by 324. And when I hit math enter enter and do that, I get 1/3. Similarly, I can take 36, divide it by 108, and I get 1/3. I could take 12, divide it by 36, and I get 1/3. So what that means is your common ratio here is 1/3, and it's positive 1/3 because positive times positive makes positive, okay? So here we go. To find now the next term on the list, I know I have 12. To get to the next one, I will multiply by 1/3. 12, and by the way, multiplying by 1/3 is the same as dividing by 3. So 12 divided by 3 we know is 4. Okay? Over here, again, you need to figure out what you're multiplying by. If you don't know, you can take 15 divided by -3, and you'll get -5. -75 divided by 15, and again, you'll get -5. You need to know, though, that this is a geometric sequence, which I should have told you. It is. Okay, so to get from here to here, again, I will multiply by -5. Sorry, not 3. And when I multiply by -5, I will get -1,875. All right, here is the formulas for an explicit formula and a recursive formula for a geometric sequence. And the same kinds of things apply. So A1 is still the first term. N is still a term number. Is it the 4th spot on the list, the 8th spot on the list, whatever. And then AN is the value of that term. So in my sequence, if I have 2, 4, 8, 16, okay, here N would be 4 since it's the 4th number on the list, but then A4 would be 16. Okay, so just be aware of that. And we will use these. And then R is your common ratio, or what you're multiplying by every time. Okay, so here we go. Write the first 5 terms of a geometric sequence for which -3 is the first term. I don't know why the spacing on this kind of got all crazy, which is A1, and the common ratio is -2. Okay, so I'm telling you that the first term is -3, and my common ratio, what I'm multiplying by, I am going to multiply by -2 every time. Okay, so -3 times -2 we know is +6. If I multiply by -2, I get -12. If I multiply that by -2, I get +24. If I multiply that by -2, I get -48. So those are the first 5 terms on that list. Pretty basic, but that's what they are. All right, here's another sequence. And again, what I want you to do first of all is to write an explicit formula for this sequence. So that's a formula that will generate this sequence no matter what term number I want to find. Okay, so this is the formula I will use right here. I know that the first term on the list, my A1, is 5. it doesn't directly give me my ratio, but I can kind of figure it out. How do you get from 5 to 10? What do you do? It has to be the same thing as how you get from 10 to 20, and the same thing as how you get from 20 to 40. So both times, or all of the times, I'm multiplying by 2. So my common ratio is 2. And then if I'm just writing a formula, I will just, I don't want to plug anything in for n. I just want a generic formula that will generate any term number I want. And by the way, this is your answer, but a really common mistake is for people to multiply that out, the 5 and the 2, and make it be like that. But you can't, because if you remember your order of operations rules, you have to do an exponent first before you can multiply. And since you don't have a number plugged in for n, I can't really do anything else with those exponents. Okay, so I have to leave it as this answer right here. Don't multiply the 5 times the 2 out and make it a 10. Okay, and now if I want to find the 20th term, that's what this means. Find a 20, which is basically what's in the 20th spot on the list. On a quiz or a test, I am not going to just let you list out 20 numbers and circle the 20th one. You're going to have to plug them into the formulas to be able to figure this out, okay? So I'm using this formula over here. A1 is still 5, my common ratio is still 2, and I'm trying to find the 20th number on the list, so I will plug that in. So A20 is 5 times 2 to the 19th power. And at this point, what I would suggest doing is that you just simply plug that into your calculator. And when you plug that into your calculator, and you should maybe practice that and check it, you get 2,621,440. So pretty big number. All right, here's a different sequence now. And in this case, I'm wanting you to write a recursive formula. And again, this is the formula that you can't find the next term until you find the previous term, which is kind of a bummer. But you have to figure out what your common ratio is. And so I want to figure out, I want to take this term and divide it by the previous term. So negative 512 divided by 2,048. Negative 512 divided by 2,048 gives you a common ratio of negative 1/2. No, sorry, negative 1/4. Okay, so that's your common ratio. If I take negative 32 divided by 128, this term divided by the previous, again, I get negative 1/4. So my common ratio is negative 1/4. Okay, so to do the recursive formula, all you do is you plug in the first term, which in this case is 2,048, and then you're going to tell me to find the any term. I can take my ratio. So I'm going to take my ratio, which is negative 1/4, times my previous term. Okay, and that is the recursive formula. That's all you really need to do is plug in your ratio. And so I'm going to plug in a number here, and I'm going to plug in my ratio, and that's all I need to do. Okay, then, in the next part, I want to use that formula to find the 7th term. Okay, so I'm using this piece of that right now. And by the way, I should also say down here that n has to be greater than 1 because you can't have negative term numbers. Okay, so here we go. So if I want to find the 7th term on the list, okay, then I'm plugging 7 in right here. And that means that I'm going to take negative 1/4 times a to the 7 minus 1, which we know is the 6th term. So to find the 7th term, I'm going to take negative 1/4 times the 6th term. Okay? Here's the problem. I don't have a number to plug in for the 6th term right now. So I better find it. Okay, so to find the 6th term, I'm going to take negative 1/4 times the one before it, which in this case is the 5th term. I have the 1st term on the list, 2nd term on the list, 3rd term on the list, 4th term on the list. I don't have the 5th term on the list to plug in. So to find the 5th term on the list, I will have to take negative 1/4 times the 4th term on the list. Luckily, I have a number to plug in there. So to find A5, I will take negative 1/4 times the 4th number on the list, which was negative 32. And when I take negative 1/4 times negative 32, I get 8. Okay, so the fifth term on the list is 8. Now I can use that, and I can plug that in right there. And I can go negative 1/4 times the fifth term on the list, which I know is 8. And when I do that, I will get negative 2. Okay? And once I know the sixth term on the list, I can plug it in right here. So to find the seventh term, I can take negative 1/4 times the sixth term, which I now know is negative 2, and then I will get 1/2. And that is your grand final answer, because your goal was to find the seventh term. But when you're using recursive formulas, you can't find the seventh term unless you know the sixth. You can't find the sixth unless you know the fifth. This right here is your grand final answer, 1/2. All right, so here we go. Find the seventh term of a geometric sequence for which the third term, that's what A3 means, is 96, and the common ratio is 2. All right, so again, we're using this handy-dandy formula. What I know is I know the third term on the list. That means then, if it's the third term on the list, think about that. That's 96. This is what I know. I know for that 96 that n is 3, since it's the third number on the list. And I know that an then is 96. So n is what spot it's in. An is the value of whatever number is plugged into that spot. That's what an stands for. Okay? So now I'm going to do that, and I'm going to use that to plug it into the formula. So I have 96 equals. The problem is I don't even know what the first term is. I don't know what the first term is. Okay, so that's going to be a little bit of a stickler. I'll talk about that in a minute. I know that the ratio is 2. Okay. And I know that I am going to use n equals 3 right here. So I will go to the 3 minus 1. Okay. So 96 equals the first term times 2 squared, or 96 equals the first term times 4. Of course, divide by 4. And A1 comes out to be 24. And lots of people will think they're done right here. So I want you to go back and read the question. The question does not say find the first term. The question says to find the seventh term. Okay? But I had to find the first term in order to find the seventh term because I didn't really know. So to find the seventh term then, I will go A7 equals my first term, which is 24. I'm still using this formula right up here, this formula. So A7 equals the first term, which I just found to be 24, times my common ratio, which is still 2. And then if I'm looking for the seventh term, my n is 7, so I will go to the 7 minus 1. So basically, 24 times 2 to the 6th power. Super common mistake is to call that 48 to the 6th power. Your order of operations, remember, tells you have to do exponents first. So you have to take 2 to the 6th first, then multiply your answer by 24. So be careful about that. When you do that, you should get 1,536. All right, and one more. How many terms are in this sequence? So right here, I know that A1 is 3. Right here, I know that n is 2 and that A2 is 6. Right here, I know that n is 3 and that A3 is 12. Here, I know that n is 4 and that an is 24, or A4, sorry, is 24. Here, the problem is I don't know n, but I know that an, I don't have a number to plug in for n, is 98,304. Okay? This we know is a geometric sequence, so I am going to use this formula again. Okay, and I'm going to plug in what I know. So I know that an is 98,304. I know that my first term is 3. My ratio, it does not give me directly, but if you're going from 3 to 6, 6 to 12, 12 to 24, I think you can figure out that you're multiplying by 2. Okay? And again, really common mistake. People will take that 3 times 2 and make it be 6 to the n minus 1. Can't do that. I need to solve for n, so I want to divide both sides by 3. 98,304 divided by 3 is 32,768. Now, hopefully you'll be able to get these as powers of the same number. So 2 and 32,768 can be written as powers of the same number. If you can't write them as powers of the same number, you can always use logs to solve these. And I will show you this both ways because it may come up in your homework that you have to use logs. So here's option number 1. Powers of the same base, or powers of the same number. And you kind of have to guess. So I know that 32,768 is 2 to the something power. So I'm just going to start plugging numbers into my calculator. Is it 2 to the 5th? Is it 2 to the 6th? Is it 2 to the 7th? And you just kind of have to guess. And 32,768 is 2 to the 15th power. And then, of course, since you have them as the same powers, you can just make a little equation out of this. 15 equals n minus 1. Add 1. And n will be 16. So that is the 16th number on the list. And again, on a quiz or a test, you're going to have to use formulas. I will not just let you fill in the blanks and write out all 16 numbers until you get to the 16th one. Okay? The other way to solve that equation is to use logs to solve it, just to help you remember. Logs is foolproof. It will work even if you can't get numbers as the same base. So if you were to use logs, what you would do is you would take the log of both sides. I'll just kind of jog your memory here. And then if you remember your log properties, this as an exponent can come out front. And then, of course, to solve for n, you would divide by log of 2. And then those would cancel. N minus 1 then would be log of 32,768 divided by log of 2. And of course, n then would be log of 32,768 divided by log of 2. And then plus the 1 power. And you can stick that into your calculator, and you should also get 16 there. Okay? So logs will work every time. Hopefully you can get numbers as powers of the same base, though. And that should do it for you.